Hello and welcome from the Washington Post Mappy Hour. We're recording this live, so we have a studio audience to talk to you guys about mapping the swirling election results of 2016's election. I'm Tim Meko. I'm the deputy here at the Post and the graphics team, and with me is Joe Fox. Hi, Joe.
Hey, I'm Joe Fox. I'm a graphics reporter at the Post.
And so let us take over your screen and away we go. Here we go. That's always the awkward part. And here we go. So here's John King on election night. This is John King likes to draw on these maps. He pulls up these maps. They're very binary. It's either red, blue, or I guess if you don't have any votes yet, they gray them out. But basically, what we see here is that all these counties here in central North Carolina, they're treating the same. So equal weight on these counties. We know that's not true. Wake County here in the middle is a very populous county. You got Durham up where Duke is, Chapel Hill is over there too. But this county directly to the west of Wake County, Chatham County, is very low population. So here's a population chart or map, density map of that area, same area. And you can see how sparsely populated that is. Here's that same map with precinct level votes. So when you look at that map and it's just either red or blue, that's an issue. I ranted on Slack all night long during the election about this. So when we move forward and you look at different ways to deal with this problem, these are all different types of maps that help try to solve this issue. They all have different issues themselves. So it's hard to see where you are in some of these more continuous cartograms. It's you lose the nuance whenever you're in just a state level map. So this has been a problem that cartographers have tried to deal with for a long time. Even trying some kind of fun, weird extruded 3D stuff as well, which is a fun way to try to deal with that. We know that there are many different variables within election results, and not a single thing is responsible for telling the whole story. So a thing that we've tried to do more and more, this is from 2016, is explore all those different variables. So this map, Laz Gamio created for us back in 2016, it has many different variables. So you got the color is a variable, it's the winner. The height is a variable, that's the total votes cast. The width is a variable, it's the number of margin in votes. And then the stroke is a different variable. So like 4 or 5 different variables here. We've figured out that audiences kind of react with these. They dig into them, they enjoy them. So that's why we wanted to push forward on this. After 2016, we've been kind of kicking around these ideas in our heads and really looking for an opportunity to use more multivariable mapping. This is a drawing that is still on my whiteboard, but I drew it back in February or early March 2020 in anticipation of the election coming up. And what I wanted to show was this idea that had been rattling in my head. It's just like I thought of it as a grass map or a hair map with many different types of variables displayed on the same type of map. So maybe you have absolute margin being the length of the hair, or total votes being the thickness. Maybe there's the left to right swing is a margin or something like that. Maybe the curve could be another thing. So this was just like a total brainstorm. Like how can we do something that's kind of weird but also interesting? We ended up doing something kind of similar with coronavirus, where we put charts on a map, little hairs, so that that thought process ended up working out. But eventually we moved into a more wind-driven approach. So we're really inspired by this hints.wind FM map that's out there. I love the way that you can kind of see where the wind is blowing, and it kind of creates this like continuous, very organic picture of where wind is blowing the hardest within the United States. And that's what we wanted to replicate. So here's the project, and I'll walk you guys through the project. So as you come in, the results here start to animate in. and it's very soothing. I found we have red for areas where votes shifted more conservatively since 2016, and blue for areas where votes shifted to the left. And then up or down was based on turnout. So we knew that in this election, turnout was going to be a major factor. It was in 2016, and we wanted to show the same in 2020. Ended up doing this really fancy fireworks chart as the key, which kind of helped explain how the particles reacted and how they were moving. So as we scroll down, we can see how this thing gets put together. We eventually deconstructed the motion on the map and only showed horizontally, left or right. And then we did the same thing for vertical. As you can see here, not many places, here we go, not many places had a negative turnout. So our turnout vectors were all in the positive range, except for a couple, 2% of counties. Then we did a comparison to 2016. You can see the massive shift right between 2012 and 2016 compared to 2016 and 2020 on the right. This is the same map that was up top. And then we went in tight on a couple different regions. So here's the Rust Belt. This is the famous blue wall, which we showed where Biden picked up 3 swing states. And then Georgia turned out to be a very pivotal state as well. So we dig in deeper here.
So let's talk a little bit about how we actually built this map. Like Tim said, it was really inspired by wind maps. And this is a screenshot of one built by Vladimir Agafonkin, who's an engineer at Mapbox and who created Leaflet, the JavaScript mapping library. And this project here by Vladimir is actually really the basis for our map. We owe a lot to Vladimir for putting this code online and sharing it with us, and to the user on Observable, whose actual name I don't know, who ported it over to Observable. That was a huge help to us because that made it so that we were able to collaborate on it and do all of these weird in progress mistakes that came out of my screenshots folder. So we found we're looking at Vladimir's code on Observable, forked it into our own notebook, and just basically started messing around with it. So I'm going to show you some snapshots in the Observable notebook to show the process that took about 2 weeks of us messing around, figuring out how the code worked and how we could use it. And this was basically the first one. We took this code that animates all these particles and we just threw in an image because we just had to figure out how the hell it works. And the really cool thing about this is that the code actually works all based on an image. So it reads the color of the image and the particles behave according to the color on the part of the image that they're on. So this is the result of that. As we kept working on that, we actually just threw in like an actual map of election results. And this, was promising, not ideal, but promising. You can see there's like a huge weird waterfall edge to the United States here, which we'll deal with later. This, I think, is a more important snapshot than it looks like. The notable thing here is that we actually figured out how to get all these points moving in all of the directions away from the center. And the key to that is this little image right here. If you look at this, you can see there's a black to green gradient going vertical and a black to red gradient going horizontal. So keep that in mind. We'll come back to that later. Here's another version that shows election results, and you can see we're figuring something out here on the edge of the map. These points aren't moving. They're still sitting there, but they're not moving. And that the key to that is this weird color, which we'll get to later. So keep that in mind. But this is really a lot of progress here. And then this is pretty much where we took it out of the observable. We got to this point, everything was working pretty well, and we thought it was time to move over to the website. But this was about 500 versions, I think, over 2 weeks in observable that we can look back on. And this was really a great tool for us to be able to collaborate on this project. So here's how it works. The basis of this map is something called shaders, and shader code's really useful to us because it can run on a graphics specific processor in a computer or a phone, and that allows us to do something really complicated like animate 32,000 particles 60 times per second, ideally, depending on what else you have running on your computer. The issue with shader code is it's a lot harder to write and harder to debug than regular like JavaScript, which I normally write. But the plus side is if you're doing this in the winter, it turns your computer into a space heater. So the process here, we start with this population map on the left side. And that's where we're determining where to create new particles. So we capped our number of particles around 32,000. And the particles are more likely to be created in a darker area on here. This map also has an alpha channel so that no particles are created outside the bounds of the contiguous United States and the floating Alaska and Hawaii. The other thing that this map controls is when the particles disappear. So they're more likely to disappear if they're in an empty area. And this will contribute to the overall look of the map, which helps to represent the population. This middle map here is the actual red and green encoded results. So we're using 2 different channels of this image, the red and green, nothing in the blue channel. And our code looks at each of those channels individually to determine the vertical and horizontal velocity of each particle. And then the final map is this colored map, red and blue and purple. And once the particles are created and their velocity is determined, then they get assigned a color based on this map. So we're really double encoding the result or the shift result here. And that really helps with the readability of the map. So let's get into those colors a little bit more. You can see this image down here looks a lot like that sort of pixelated version that we had in the observable with a black to red gradient going vertical and a black to green gradient going horizontal. And like I mentioned before, the green channel actually controls the horizontal movement of the particles, and the red channel controls the vertical movement of the particles. So if you look at this weird kind of pukey green color on the outside of the United States, that's actually 128 red and 128 green, which is exactly halfway between 0 and 255. And so what that means is if a particle goes outside of the bounds of the United States, it'll stop moving and it'll disappear. And we already know because of the population map with the alpha channel that nothing's getting created out there. So we've solved that issue from before where there's tons of stuff on the outside of the boundary. So this is the full set of images that we ended up using for that map. You can see over here we have a green channel, everything encoded in the green channel. The red channel is just halfway between 0 and 255. This is the same thing, but with red. And then this is the combined one we saw before. The line work just goes on top. That's just a PNG with transparency. And we've already talked about density and color. So let's get into some decisions that we made to make this map readable and informative. The left side, we can see an animated screenshot here of an earlier version in the observable. And what I want you to notice here is how the particles, when they get to the edge of a county, they change direction instantly. And that's definitely a more precise way to present this information. That means that at each pixel, the particle is exactly representing the county that it's supposed to represent. And that's great if we're trying to communicate something precisely. We didn't think it's as visually appealing. And the point of this map isn't exactly to communicate precise information about each county. So what we decided to do is actually blur that color layer. And that gave us these nice curving lines that look a lot more like wind and allow us to see trends a little bit better. And we're okay with it being less precise because if you want to see the results for a specific county, you can see that somewhere else on WashingtonPost.com. This map is not intended to give you that precision. So a little bit more about these decisions we made. And here we want to talk about the population stuff. So we have a layer that controls, where the particles are created, and more particles are created in places with more voters. That's great. But another way that we're kind of weighting the visual weight of these areas is based on how much the results changed since 2016. So if there was less change since 2016, the particles move slower and they're more likely, they disappear more quickly, which gives that area less visual weight. If you look at like Cleveland, for example, Cuyahoga County, the particles are moving pretty slow, disappearing pretty quickly compared to like the Columbus area where you've got a lot of particles moving fast. And so they leave a longer trail, they stick around longer, and they're a little bit more visually noticeable. And so that gives us a little bit more weight to the interesting areas.
So all this to say, the whole dang project runs off of images. And so once we figured out that critical stack of images, we know that it's going to work for other places. So, we did it for at the national scale. And then we were able to say, all right, the Rust Belt was pretty important. Let's rip that out. So we changed the print composer, ripped out 6 or 7 images for the Rust Belt, and we had it. It was done. It was an easy copy and paste and change the file paths. We did the same thing for 2016. You saw 2016. We did the same thing for Georgia. I think we also had Arizona built at one point and ready to insert it into the story. All that came for free because we figured out the work at the beginning. So it was very efficient in that regard. And it allowed us to update as we went. So that QGIS workflow actually worked out really well, where we had one layout, we had all the layers, right? And then we had a layout manager that had 7 different pages on it, or 6 different pages on it. And we, all we had to do was hit export, and it spat out those 6 or 7 different files. And then we pushed them up to the repo and they were updated. We also knew, and we expected that, since every state was a mail-in, many states at least had mail-in votes, that counting was going to be slower. So we built in a way within that line work file, just with the borders and stuff, to block out certain areas that did not have a sufficient number of votes to create an accurate picture. The version that we showed you has all the votes in it because it's now 2021. But early in the project, we had to plan for that. We knew it was going to be a little bit slower. We published this maybe the Thursday or Friday after the election. We knew that those results would continue to evolve as we got more votes over time. And then we also knew that we would want a print component. So we thought about how we could make this into a print page. This is the biggest map that I've made at the Post, but it's a nice big full-on double track. Again, playing up that firework key really prominently, and then giving lots of map notes and annotations, really labeling cities extremely, almost to a point where they're too many in some places, but like you could see like with these population areas where they were and why you had jets of blue coming out of Salt Lake City, for example, or other places like that. So this was the print page. I believe that's all we have. I think this is it was a very fun project. It was all based on experimentation and iteration, and one that I'm excited to get to talk about again. So I'll be happy to answer any questions in the NACIS Slack, or shoot me an email or on Twitter. So yeah, thank you.